So today's job is a Bugfix. I've noticed a problem with this Perl script here. This Perl script is called taxon constraints. It will read phylogeny and read a bunch of species from, say, a DNA barcode alignment, and it will figure out what in the source tree is monophyletic. It will find the monophyletic taxa, and it will create a corresponding set of binary constraints for the taxa in the sequence matrix. Now, what I've just noticed is a problem with this. Now I've run it on a small phylogeny. We can take a look. It's here somewhere. It's this one. No, it's the something else. It's a small phylogeny. There's a lyric format version. There's not many species in here, 30 or so. And you can see they're all of a single genus, Armadillo. This is a genus of bees, and one outgroup. So I've run the taxon constraints script on this, and it's making. I notice it's making constraints far beyond the range that it should be doing. Armadillo is fine, monophyletic, and applied as a constraint, but also it goes way beyond, which I thought it should do. The tribe certainly should not be considered the family, since this is a phylogeny of just one genus. So this needs fixing. You can see the family and subfamily here. So it's going up to ranks it shouldn't be doing. So this is a job today to fix this. We need to find this, stop it doing this. So here's the script we need to fix. So quick look through this. Perl scripts. I have a first subroutine is for reading the commands at the command line. You can see them here. Bunch of settings. Reads the NCBI taxonomic hierarchy, taxonomic database out of 2 files. This is present in 2 files. They're downloadable from the NCBI file FTP site. Reads a FASTA file. So the script is designed to constrain species comprehensive sequence datasets such as a DNA barcode alignment. So here it's reading the FASTA file. Recording the backbone tree, and then traversing the backbone tree and assigning taxa to internal nodes and testing for monophyly. and then going through all the members of the species which alignment, and deciding how these, making a new character matrix is a binary matrix for these. Okay, so probably the list of constraints is held in, is looping through that here, through this array. Let's have a look where this is in this hash. The array is created from the keys of this hash here, and this hash is being filled out here. So in trying to figure out where we need to be working, this is not great here. Like for example, I'd like to have a note here which says what this array is, and I haven't got this, so it's not great. It's derived from the keys of this hash here, so that it would be useful here to have a note what this was. Although it's rather, they have at least used quite a descriptive name for the names of the array. They do. Although long, this can be used. This can give some useful information. So this hash, all tax names for these terminals. So perhaps this contains all taxonomic names. Okay, so after a bit of head scratching, I think this is where we should be assessing each putative monophily in the aspect as is it inside of the range we should be considering, because here we've got a bunch of counts. So let's have a look at maybe a lot of this has been printed to one of the logs. So let's rearrange this a bit and make it easiest to print all this to screen. Okay, so this needs to be format is slightly different for making a version and printing. It used to be so the full stop for the period is a concatenation function in this context. So what do we have? So it's looping through all tax names for a given node of the source tree, and we have tax name assigned to the node, recorded as monophyletic, and we have some counts. Count totaling backbone terminals. What is this? So probably this is the count of this particular taxon, which has been recorded over all terminals of the source tree. And how many from this particular node? So essentially this is going for each taxon and is counting. It's a simple test of monophyly. If this taxon name, is it present in all descendants of a current node, and is it elsewhere on the phylogeny? If all the descendants of a current node are of this taxon and the taxon is not found elsewhere, then this is a monophyletic group. So I think we also need to have a count here just to check the total number of assess this against all the account of all terminals. So if this is also equal to all terminals of the phylogeny, then this should not be considered, because this is not really considering anything else. So we need we need to add another conditional here. So we need to count how many terminals of the source tree have we retrieved taxonomic information, because this might be a subset of the. Often is a subset. Some terminals are not even present in the NCBI taxonomy, for example. So we need to account for this also. So here we're navigating the numeric string. And here is a test for, is this an internal node? If it's an internal node, this this section is not run, so these will be all terminals. So all the terminals are the hash keys of this. So we put all the hash keys, i.e. terminals, into an array, then we can count them with the scalar function. So here we'll now have a count of all the terminals in which we are considering, which are one of the ones which we retrieved some taxonomic information from trying to match with the NCBI database. So now we need to go back to, where were we? No, that's not written for some reason. I'm messing around with this object, maybe used somewhere. It's kind of awkward to find. Well, I think I'll do it instead. I'm going to create a new. I'm going to create a new object to use to do our job today. Let's find again. So I'll just it's kind of repeated, but so I need to call this something else. Terminals is taxon found. Although it's not actually in the right place either. It needs to be here. Okay, terminals of taxon found if the lineage has been retrieved for this either the binomial or the genus name. Okay, so we'll use this instead. Go back to modify this. Still don't have a count on there. We're even looking in the right place. How many terminals? Oh, okay. The problem was writing these as local variables, which I'd be surprised because it's not actually in any kind of loop or anything, or conditional. But anyway, so that was our problem. Let's go back to where we were now. So now we have a count of all the terminals of the backbone tree, just ignoring those in which we don't know what the taxon is, and here we need to check if the modifier test we're considering is or is not the same size of that. So for instance, taxa calculator, which is quite a high rank. Certainly all members of this genus are for this. So that will be count 18. So if that's the same as all the taxa, then we shouldn't be considering this at all. Amygdala 17, fine, test this one. Bunch of Anthophorini. So shouldn't be considering this one. The main one I want to check is the family Apidae 18. Okay, so if the count total equals all terminals, then we should not consider this. So I think we'll have this here. Okay, save. let's look at the log file. Okay, so now we do have an expected result now, and that only this is a tree of Amygdala, so only and it's monophyletic in this tree. So and we've now only found out monophyletic. However, in this particular, this is a log file which I use, and actually I don't want to print this here because it's not really testing whether or not this is monophyletic. So the job is it's kind of done, but I just want to clarify this for the log file because this is something I use. Let's rearrange this a bit. Yes. We've got the key name wrong. Should be job done now. We just need to check the main output file. Check that is also okay. So there's should be so job done. So we had to fix a bug. It was making taxon constraints well outside the taxonomy range of the source tree. It was effectively doing it for higher taxa, and we have fixed that. This tree is very specific. It's just for a single genus, the Armadillo, and you can see hence just a single taxon constraint inferred for Armadillo, being monophyletic. So these are soft binary constraints. This genus is not Armadillo, so this is a 0. These are Armadillo, so these are 1. And a single, in this case, a single constraint for this source tree, but in much larger range source trees you can get quite a large number of characters. Okay, so we've fixed this bug. We should make a note of this. Okay, job done. So this is part of, I'll delete this now. This is part of a loop. So inferring taxon constraints for all these source trees, about 15 or so of these source trees. Loop through these, make a taxon constraints and concatenate these. We can have a look at the, let's have a quick look at the, so we have a DNA barcodes here, and these taxon constraints are here. Need to look at a set of source trees. Okay, job done. Until next time.